this is a relative motion question. Typically, a lot of the times it's going to be a boat in water or a plane in the air. And this one is about crossing a river. So, in any relative motion question, you always want to write this equation. So, the velocity of the object, so in this case, the boat, with respect to usually the ground or whatever like the most fixed reference frame is. So the boat relative to the ground vector is going to be equal to the boat relative to whatever medium it's moving through. So for a plane, that would be air. For a boat, that would be water. Plus the velocity of that medium, the water or the air, with respect to the ground. So you can see here the B and the G end up being the ones on the outside, and then the inside ones match. And that's the standard formula for any kind of relative motion question. So always write that equation on relative motion questions. So now let's sort out from the stuff we were given in the question which ones correspond to those variables. So it's asking for the velocity of the canoe relative to the shore. So that is the velocity of the boat relative to the ground. So the velocity of the boat relative to the ground, that's what that notation means. That is the thing we're trying to find. The velocity of the boat relative to the water. So whenever it says, for example here, a canoe operator paddles 3 kilometers per hour north, that is describing the direction that they are trying to point, or that they are pointing relative to the medium that they're moving through. So in this case, that's boat to water. North. Now, anytime they give you like a wind velocity or a current, that is going to be your water to ground or air to ground velocity. So in this case, that's 4 kilometers per hour west. So based on this vector equation, if we want to know the velocity of the canoe or boat relative to the shore or ground, we need to add as vectors the velocity of the boat relative to the water plus the velocity of the water relative to the ground, and that will tell us the velocity of the boat relative to the ground. So the way I think of this is, if we imagine this situation, so here's our river. We've got our north, south, east, and west. We have a boat, and the boat is trying to go, they're pointing straight across relative to this water and moving. So this is boat to water is 3. Then the current is pushing this way, water to ground. And the combined effect of those two things is that your boat is going to travel along a path something like this. So you're trying, in your mind, you're just pointing and looking straight across and paddling, and you're moving forward, but also the current is pushing you to the left. So overall, to someone standing on the shore watching, you're following this orange path, and you're going to end up hitting the shore somewhere over here. So I like to think of the velocity of the boat to ground or plane to ground as your sort of actual path. The boat to water is where you point. The boat to ground is the path that you actually take relative to the shore, if someone was watching you from the shore. So in order to calculate that, we need to add those two vectors to get the magnitude of that orange vector. But we can't just add 4 plus 3 equals 7 because they're not all pointing the same direction. So we have to add them as vectors using Pythagorean theorem in this triangle. So velocity, this here is velocity of boat to ground. So velocity boat to ground squared, because it's the hypotenuse, is equal to the velocity of boat to water squared plus the velocity of the water to ground squared. That's just Pythagorean theorem on this little triangle. So velocity boat to ground squared is equal to 3 squared plus 4 squared. So that's going to be 9 plus 16. And now if we square root both sides, we end up with that. Velocity of boat to ground is just the square root of 25, which is just 5. Okay, so we have the magnitude now of that orange vector, but it's a vector, so it needs to have a direction also. So in order to describe where that vector is pointing, we need now to find this angle. But we can do that using trig ratios. So tan of that angle would be equal to the opposite, which would be the 4, divided by the adjacent side, which would be 3. So theta would be equal to tan inverse of 4 divided by 3. And if you calculate that, you should get 53 degrees. So then we can state our final answer as the velocity of the boat relative to the ground is equal to 5.0 kilometers per hour north, 53 degrees west.